Have you ever wondered how we precisely control significant amounts of electrical power using only a tiny signal? It is a fundamental challenge in many electrical systems, from industrial motor control to high-power switching applications, where robust and reliable operation is absolutely essential for safety and efficiency. An SCR gate triggering mechanism enables a silicon-controlled rectifier to switch from its blocking, off-state to its conducting, on-state by applying a small control signal to its gate terminal. This gate signal acts as the catalyst, allowing the SCR to carry substantial current across its main terminals, the anode and cathode, thereby controlling power flow to a load. The core principle lies in the SCRs for layer PNP-N semiconductor structure, which can be visualized as a pair of interconnected transistors, one NPN and one PNP. When a positive voltage is applied to the anode relative to the cathode, the SCR initially remains off and blocks current flow, much like an open switch. However, when a small positive current is introduced to the gate terminal, it forward biases the gate junction. This gate current effectively turns on the NPN transistor in the two-transistor model, which then supplies base current to the PNP transistor. A regenerative or positive feedback process quickly ensues where each transistor drives the other into saturation, rapidly reducing the SCR's resistance and allowing it to conduct heavily. This self-sustaining action means the SCR latches into the on state, and the gate signal is no longer needed to maintain conduction once it has fully turned on. To trigger an SCR, engineers typically apply a short-duration positive current pulse to the gate. This pulse must have sufficient amplitude and duration to ensure the SCR reaches its latching current, which is the minimum anode current required to sustain conduction after the gate signal is removed. Common methods include DC triggering, which provides a continuous gate current, or more often, pulse triggering using a narrow, high-current pulse from a pulse generator or a unijunction transistor. A C-triggering can also be used, where a part of the alternating current cycle is used to provide the gate current, allowing four-phase control applications. Understanding the precise requirements for gate current and voltage is critical, as too weak a signal might fail to trigger the device, while an excessively strong or continuous signal can lead to overheating or loss of control. The SCR also features a characteristic called holding current, which is the minimum current that must flow through the anode to cathode to keep the SCR in the on state once it has been triggered. If the current drops below this holding current, the SCR will automatically turn off and return to its blocking state, even if the gate signal was still present, highlighting its unique latching behavior. Mastering the gate triggering mechanism of a silicon-controlled rectifier provides you with a powerful tool for efficiently controlling high-power circuits. It enables robust and precise management of electrical energy, giving you the ability to switch devices on and off reliably with a small, calculated input, which is a cornerstone of modern power electronics design.